Entanglement is an aspect of quantum mechanics that many even who developed quantum mechanics found distressing and unexpected. And it emerged in its fullest form in a paper that Einstein wrote with two colleagues, Podolsky and Rosen. And basically what these guys found is that according to the mathematics of quantum mechanics, they found that you should be able to set up two particles, one particle, say, in New York and the other in Los Angeles, each of which was in an indefinite state. They framed it, in fact, David Bohm framed it in the more modern phrasing in terms of something called spin. So let me use that. A particle can spin. If it's spinning clockwise, we say it's spinning up. Counterclockwise, we say it's spinning down. So the idea is you can have these two particles, distant locations, each of which is, in some sense, spinning up and spinning down at the same time, 50% chance of each. The crazy thing that they found was if you go over to the particle in Los Angeles and measure it, it snaps out of the haze and, say, spins up. The one in New York, according to math, at that very moment snaps out of the haze and spins down, even though you didn't do anything to it. And you can reverse the experiment. If you measure the one in New York, it spins out, say it's spinning down. The math shows at that very moment the one in Los Angeles will snap out and spin up. This is nuts, right? This is what Einstein called spooky. Spooky action at a distance. You do something here, and it seems to instantaneously affect something over there. Einstein said, come on. That can't possibly be how the world works. How could something you do here affect something over there with no time delay, instantaneously? So his conclusion was, it must be the case that quantum theory is telling you that that particle has a 50% chance of being up or down, but it really is one or the other. The quantum laws simply can't tell you which. And therefore, the quantum laws are incomplete. They are not giving you the full description of that particle. And that was his challenge. He, in some sense, threw down the gauntlet and said, this is proof that quantum mechanics is not a complete description of the natural world.